Okay, today we're going to look at logic statements. And this is really just a follow-on from the last two lessons, and the last little bit we'll have here on logic. Logic statements are typically things that are written out in English. So here we've got a logic statement: you will get homework if I am angry or you are lazy and it is a school day. Okay, now this is part of the problem with English, in that there's a couple of different ways that this statement could be interpreted. I'm going to interpret it one way, but I'm sure you could find a different way in which it could be interpreted. So, but first of all, to sort of tackle this and sort of convert it into logical symbols, we need to work out, well, what's our input, what's our output. So our output is homework. Are you going to get homework or not? That's the output, that's the result of this statement, whether you will get homework or will not get homework. What are the inputs? What are the conditions that determine whether or not you don't get it? Your inputs here. Well, we've got angry, you've got lazy, and it's a school day. So what we often want to do is just give symbols to those. So we need to define this. Just usually any sort of maths equation you're doing, if you're introducing variables, you need to define your variables. So here I'm going to say, well, let A equal angry, B equals lazy, C equals school day. Those are my three inputs. And my output, I just call that O for output, equals homework. Now I can rewrite this statement. My output, O equals, and now I said, if I'm angry or you are lazy, A or B. Now I put my brackets there to make it clear we're going to resolve this one first. So now there's no ambiguity. In the English language, there is ambiguity. And C, and it's a school day. Okay, so that is what I've done here. I can now write this down as a logic table. And so this is the logic symbol for OR. This is the one for AND. I think I said before, in the IB, you can just do a circle and put the word OR inside it, and here a circle and just put AND inside it. So you don't have to remember the symbols, just put a circle with the word you're using, the logical gate that you're using. But you see I've wired it up here, I've done A or B. So A and B coming into there, and then the output of A or B becomes one of the inputs into my AND. C is the other input to AND, and then that's the final output there. Of course, we can also write this as a truth table. So we've got 3 columns there, so I need to set my 3 columns for my inputs. That's going to give me 8 rows, and then I can show the values for all of that. And again, that's something you might be asked as part of the IB question. Okay, here are some videos which you might find useful. This one talks on Boolean logic and logic gates. It also talks a little bit about how the transistors are used to create these logic gates. And this one here, again, quick introduction to the 3 key logic gates. Both very useful resources. Make use of them as you get yourself ready. In the coming weeks, I will put together some questions so you get to see the type of questions you can be asked on these topics. So we've looked at computer organization, we've looked at from very high level, hardware, operating system, software, coming down to binary arithmetic and the logic gates.